In the construction industry, 25% of lost work is attributed to back injuries, which is significantly risking construction workers' safety and productivity, resulting in an annual cost of $14 billion to construction companies. Therefore, it is our role as designers to incorporate health and safety issues in our designs for the construction industry.
So let me first think about the wireless devices themselves, or the sensor devices themselves. There's a set of sensors in there that are enabling a different way of tracking activities. And so what we're doing is trying to say, well, could we use those for other industries? Have they advanced to the point where we could use them for, say, a construction industry?
Another challenge is scalability. How do you get multiple individuals to capture data across sensors? Using a construction work group as the initial case study is interesting and highly ambitious because of the variability that exists outside.
So when you're collecting information, it is very important to be very clear who you're targeting and what are their concerns as far as privacy is concerned. They may not be happy with a database having all these details about their personal information.
Right. In our project, we are developing a prototype for the construction workers that helps them in reducing short-term as well as long-term injuries. User interviews are considered as the most valuable in designing a product, since users are the people who will use the final product. Hence, we have conducted user interviews with the construction workers from 4 different construction sites located in State College, Pennsylvania.
It's really important to get the voice of the customer in order to understand their needs and wants and desires, and to ultimately have buy-in to your system and know how to correct those procedures. So interviews provide the context for which to do that. So the content analysis allows you to look at themes across your sample and identify the state-of-the-art or the future directions of the project in a rigorous and validated method.
Content analysis of user interviews revealed that bending and lifting were the most repetitive movements on the work site, and most of the workers noted having recurrent back and knee pains. We also learned that we cannot use mobile phones as an alarm modality at the worksite, since the sites are very noisy and the workers are not allowed to carry their mobile phones. Also, most of the workers noted that their activities are not affected by vibrations at the site, and hence we can leverage vibratory forces to alert the users in case of a back posture.
Following up on the content analysis, our team developed the first rough prototype having construction workers in mind. We thought of embedding wearable sensors and notifying devices in a high visibility vest. Such device would be accompanied by a smartphone application that provides feedback about the information collected by the wearable sensors. For the low-fidelity prototype, our design efforts were actually focused on developing the smartphone application, taking into account that sensors provide detailed data and that data must be summarized to actually be useful. The low-fidelity prototype has been tested with non-expert users, which were asked to perform a simple bricklaying task.
Researchers have deemed posture to be unsafe when the worker's torso angle is greater than 25 degrees while carrying a load. Our low-fidelity prototype was based on the RULA risk assessment, which assesses for the risk of incurring serious injuries based on a risk score of 1 to 7, with 7 being the most severe and 1 being the lowest, or a negligible risk.
The feedback on the low-fidelity prototype led to subsequent iterations of the smartphone application, making it more user-friendly and more informative of the user's posture performance, as well as providing tips on how to improve it. We also worked on the notifying nature of the high visibility vest, which now gives its wearer feedback about his posture in real time through vibration. Contrary to the low fidelity, the medium fidelity prototype was tested with construction workers, which provided valuable feedback through a survey on the system's usability, as well as its influence on their awareness on health and safety in the construction site.
The usability test was meant to evaluate the user satisfaction and perceived health and safety awareness from using our prototype. Statistical analysis revealed that the vibrating sensors are the most usable amongst our 3 design configurations. Overall, all the 3 conditions contributed in increasing health and safety awareness, and our design solutions were more informative and engaging than the existing techniques.
Therefore, the team recommends a technological intervention in the construction industry, as construction workers valued our design solutions to be more informative and engaging, as well as an enhancement of safety awareness in the construction site compared to existing techniques.